So let's get started. Hello, everybody. My name is Donovan Slubbert. I am a second-year PhD student. I work with Dean, both of us under the supervision of Prof. Francesco Petruccioni. And welcome to today's micro-school on GitHub, Introduction to Git and GitHub. I'm just going to read Dean's bio here, and then he'll get started. Okay, so here we go. Dean is a second-year PhD student in the Quantum Research Group of Stellenbosch University under the supervision of Prof. Francesco Petruccioni. His current research focuses on the intersection of quantum computing and neuromorphic computing to find an optimal hybridization of these technologies. Dean completed both his BSc and BSc honors at the University of Witwatersrand, majoring in astronomy, astrophysics, and theoretical physics. After this, he completed a NITheCS internship with Prof. Petruccioni and Prof. Ilya Sanaisky under UKZN, University of KwaZulu-Natal, which was an introductory research project on quantum computing. This then led to a master's degree with the same supervisors at UKZN, which was based on the application of open quantum systems techniques to model the noise of IBM quantum computers. His research interests have since evolved to include machine learning and quantum algorithms, which are central to the idea and aims of neuromorphic quantum computing, especially for applications such as artificial intelligence and deep learning. And with that, Dean, I'm going to hand over to you. You can get started whenever you are ready. I'll let you know if we can see your screen. Thanks.
Great, thanks, Donovan, for a very good intro. I'll share my screen now just to test if it's all working. That it should be. It should be just the web page of the GitHub.
Yes, we see that. Thank you.
Okay, so welcome everyone. I wanted to just give a general introduction to the topic of what we're going to be talking about today before we get into the hands-on, because this is a very tricky topic to give a lecture or a hands-on about, because while it is a very simple and very, very useful bit of technology with Git and GitHub that is everywhere in software development, and everyone should know how to use and how to be proficient with, it's kind of tricky to get started with, because as soon as you start looking for things, it's very quickly gets overwhelming with all of the different new terms and all the complicated things, and it seems like there's just so much going on. And that's a bit of a blessing and a curse of GitHub and Git, is that they are both very, very simple to get started with, but they can do a lot of advanced things. And it's kind of unclear where that line is drawn when you're just getting started with it. But as you become more and more familiar with it, it becomes really, really useful. And all of its features and all of its tricks and tools just become, they seem like you want them everywhere for every little thing that you do with coding. So first, I want to, I guess, cover the idea of what is the difference between Git and GitHub. Git is a very useful piece of software that comes with every Linux and Mac computer by default. So with Windows, it's a very easy installation. This is the Git fast version control. This is the very basic site. You can very easily download and get it installed. And GitHub is the website where Git repositories are hosted and shared. But I will talk about what repositories are and what it means to share your Git projects and things throughout the intro of all of this. But yes, for Git, to give an idea of what it really is, everyone always says that you should use it and that it's very important to keep track of your code and all of these things. But really, it's just a way of saving your code and keeping a very good and detailed logbook of all of it. So to say that you don't use Git or you don't really want to use Git, it would be like having a file code, but you can't save it. Every time that you open it, you have to do a little stuff, and every time you close it, it's gone. This is a more advanced version of that, which is, you'll see what I mean when I say that you'll wish that you had it everywhere. To give a few illustrative examples of why you would want it everywhere, I can give a few examples of places where you wish that saving could be more comprehensive and more useful. So if you imagine a situation where you have your code that you've been building for a while, it's maybe 1 or 2 files, and you've been adding a bunch of functions to it, you've been adding all of the comments, all of the nice things, it's working very well, it's working nicely, it does the basics that you want it to do. Then you get an idea, okay, you want to add some more functionality to it. You want to do more functions, maybe some classes, maybe anything else. Then you start working on that, then something breaks in your code and it stops working the way that it should. And you think, okay, cool, that was a bad idea. Let me just undo and start from scratch from this new version. Then you try and undo a bunch of things. You try and delete some code that you wrote, but then you think that you got it back to the original state where things were working, but it still breaks and it still doesn't work. Then you really start sweating, you start panicking, because then you think that you've ruined your entire code base and things are just broken and you don't know what to do. And you can't undo everything because the undo function only goes so far. Now, also, you can imagine the case where, let's say you've been working on some code and you've had a few different files come in and out, and you've made a few, deleted a few, and you deleted something a few weeks ago that you thought you wouldn't need anymore. But then you get to the point where you think, there was something in that file that was very, very important. Just one line that I wish I could just go back to and see, because now I really need it. But you've forgotten it, you've deleted it, you've cleared your recycle bin, it's gone. It's poof. Then you really, really wish that you had it back. Or another example where you might want to add some new features to it, but you've learned your lesson from fiddling with the main file, and you want to keep that version very safe, very separate, and you don't want to mess with it. So to add this new feature, or add this new experimental functionality, you make a copy of your file and then you add some stuff to it. But then you have another idea and you copy that file, that first file again, and then you do some other changes to it. Then before you know it, you've got 3 or 4 files with different features everywhere. And I think, oh, well, how do I mix those? How do I put them all just into one working thing? Because one of them has one feature, the other has another feature. The main one is still the main one, but that one works, that you know it works, but you can't really consolidate all of that. Git solves all of these problems, and very easily, and that's the whole point of it. Because usually now with those problems, you'd think, okay, well, I just need to make a little logbook of all of the changes to the code that I make, so I make sure I know how to undo exactly how to get back to the point where it was working. So you take out a literal pen and paper or type up a notepad and make all of the changes to your code and keep track of every single little line that you made a change to. Or then, like I said, you would have a bunch of different files that you just copy and paste a few times, and then you add all your features, and then, well, you've got 6 different ones that say final project, final version, v2 final. But then you don't know which one it is, and you don't know how to consolidate all the changes that you've made across all the different versions. Git takes care of all of this in a very, very simple and easy to use way. And for this example, I'll now get into the hands-on demonstration. And for this, I'm just starting in a basic terminal, because Git is fundamentally a command line tool. There are nicer ways to use it, and I'll talk about those as well. But for now, to keep it absolute very bare bones basic, I think it would then also help just for a little story of where Git came from. And it was actually created by Linus Torvalds, the creator of Linux, where he just wanted a way to keep track of all of the changes that he was making to his code, and to Linux specifically, because that is a very, very big project and very hard to keep track of everything. You can't have a paper and pen notebook making all of those changes. So he created Git, and that became very, very popular, and very, very quickly became the most popular version control system that there is. Now it's everywhere. Everyone knows it, and everyone should know it. So here I'm in just a new empty folder with nothing in it. It's just blank. But this will be the starting point of the project. And you can imagine this is now where you start your new coding project. You've got your idea, you've made the folder, you haven't made any code yet, but this is where you start. To get started with Git, it's very simple. Once it's installed, or if you're using Mac or Linux, it's already installed, you just type git init for git initialize. Then you'll see here, you've created a new repository in here with this .git folder, which is hidden, but it's the little folder that keeps track of everything. Now I can, for example, make an empty file, which I will just echo now into a text.txt, which is just an empty file that's there. And now I want to have this stored in my repository. I want to save the file, essentially. To do this saving of a file in this Git version history chain, I have to add this file to the staging area, which is just Git's fancy way of saying that, okay, it's now focusing on those files, that's what it's going to be keeping track of. You can add a single file just like that, or you can add your entire folder just with a dot, and that will then take every file that's in this directory, in this folder, and add it to the staging area. Once that's added, now you can see even on my command line, it's got this little plus showing that, okay, there are things in the staging area ready to be saved. And this is just kind of an in-between area in case you want to add some stuff and then take it out before you go and commit it to the whole history of everything that's been saved. Once everything's in your staging area, then it's very simple to just git commit. And that means to commit it and add it to this logbook of yours. I was going to say usually, but every time that you add a commit, it's very, very useful to add a little line to say what you're doing with it. Usually it's just something simple like your first commit, if it is your first commit, but you can imagine like that example that I was talking about when you have your 6 different files and this one's the final and this one's the final with edits and this one's the final real final one. Every time that you add one of these things, every time you add a new function or you add a new class or you add a new something, you want to keep track of what you are doing to that file. So with this one now on the history book, I can go back through the logs and I think, oh, where was the time that I added the function to say, to print the final hello world at the end of the file, for example. Then I can go back and look at the message that I put, which was added hello world function. Then I know exactly, okay, that was the point in the logbook. That's the one that I need to go back to. This is where everything kind of fell apart when I made breaking changes. But usually for this one, you can just put it as your first commit. Typically, it's also when you add your README file to the repository, which is just a markdown file, text file that introduces people to the repository or introduces yourself to explain everything that's going on there. It's just a nice little interface to explain all of the code. But this git commit part, this message is with the -m flag, and eventually this will become muscle memory to just -m and put a message. And then you can see it's made the changes, added the commit. It's not added many lines because this is just an empty file. It's not deleted anything, and it's done. It's committed to the repository. And then you can go git log to then see, okay, at this point on this Friday, with the message first commit, we committed this. We added this file. This is the hash which identifies this log in the logbook. And then, for example, I can add more files, or I can echo something more to yeah. Echo just the word hello to my text file so that it just says hello. Now, if I want to then update this into the Git history, then I can git add everything again, and then git commit, and then say what was happening. Yeah, now that's been done. I can git log and then see what's been changed again. Now you can see there was the first one and then the second one, which is this is a completely different iteration in the logbook, a completely different entry that's now been added to the Git repository and to the timeline, essentially. But now let's say, okay, whoops, I don't really like this. If I don't want my file to say this anymore, I just want the empty file. I want to go back to this part. Then what we do is we just copy this hash and I go git checkout with this hash. Checkout, you're going to think of it, the terminology comes from if you're in a library and every little thing that you've written is a book on the shelf. And you've got the book that you want, and then you have to go and check it out at the front desk. I can git checkout, and then now if I do this, I'm back to an empty file. So and now I've gone into a new branching part in the timeline, a new branch, where you can imagine if you've got now your main path, your main logbook timeline of all of the different commits that are going along. If you want to branch off from that and try something else that doesn't influence the main version, now you're working on something else, you go into a separate branch. I'll elaborate more on the branching idea, but for now, this is our first exposure to it. If I do look at git branch, then I can see that I'm on this head detached at this hash. which just means that it's another new branch of somewhere in the history that's been detached from the main branch, and now I'm working back in time where I had the empty file. And then I can go and add something else to this file and then push it back into the main branch where everything is united again. But for the example of mixing branches and that, I'll do a bit of a better example than just going back a branch. Now, so to go back to the main one, I git checkout master, and now I'm back where we started, where everything is again. There should be a hello in my text file. Now I've just gone back between versions again, but both of them are still there, so I can always go back. I know this is a very trivial example, a very basic idea, but you can imagine when you've got much bigger projects and you really, really need some important stuff that were in old versions and you don't want to mess with things, that jumping between this will feel like a lifesaver. Now, if I've got this idea of I don't want to break the code that I've got running right now, even though I know this is just a text file, but the same idea can be passed on to any files. If I don't want to break the version that I'm on right now, and I want to branch off onto something else just to try something and see if it works, and if it does work, then I can unite it back into the main file. Then what I want to do is use this branching functionality, where I want to break off a new branch, which is separate and leaves the main one alone, which is typically called master or main. It depends on Git and GitHub, and sometimes it changes. And I mean, sometimes like very regularly, but just to keep track. Maybe older versions say master and newer versions say main. I think GitHub says main and Git says master, but they are fairly interchangeable, and you can rename them, just make sure that they match. Now, if I do want to branch to try something out, I can either git branch and make new branches, or I can just already check out -b, the B flag, which will make a new branch and check it out automatically. And I'll call that branch. Now I've switched and I'm on the new branch. I'll go to git branch, then it'll tell me, okay, there's master, and there's branch, which is currently what I'm on. Then if I want to make another file called app.py where I'll keep my Python code, then that's added app.py. Now I can git add all of my files, commit again. Say what I'm doing, and then then it's now committed. So now if I see that it's working and I've made sure that, okay, everything in this branch now with this additional file, all of that's working, then I can switch back to my main master branch. And then if I want to pull in the newer version with this new file into my master branch, all I have to do is git merge. It says no remote merge. Okay, that's another issue with remote repositories, but don't worry, this usually works. This is part of the live demo. Some things might not look like they're working, but it is with git merge that you then pull in your branches. Possibly with, yeah, sorry, there you go. If I go git merge branch, then that pulls in this branch named branch. And now that's been fully incorporated into the master, which now has this app.py on my master branch. So now that does accelerate me a little bit into talking there about this idea of remote repositories, which I mentioned. And for that, it's a very good segue into talking about GitHub rather than just Git, because while this works as you're saving and keeping track of all of your local files, what happens then when you need to share your code, when you want to have a look at if you're a student and you want to show your supervisor some code, or you are in an interview and you want to show them your portfolio of the projects that you've made. You don't want to have to take your laptop and then show them and be like, look, these are my folders and my files of all of the code that I've written. You want to have it somewhere that's easy to share, easy to maintain, easy to keep. Also, if you have the idea of I want to make my code open source. How do I do that? How do I open it up to the world? Do I have to make a whole website to give the code to someone? Do I have to make it a downloadable thing? Do I have to load it onto a Google Drive and share the link around? Those don't really work. They miss out on a lot of features. So that's the point of GitHub, is to take this Git repository with all of its history and all of its changes and all of its functionality and put it onto a website where it is easily shareable, easily interactable with, and other people can very easily contribute to it. By also then going through this process of breaking off a branch, making some changes, and then pushing it back in. Even though with remote stuff, it's a bit more involved than that, because you can't just have people putting random things into your code that they make up that might destroy it. So then you ask who has the control over the repository. And that's where sharing and pull requests come in, but I'll talk about that more now. You can also then, on that point of open source, you might ask, well, what is open source and what really happens with open source? What does that mean? What you've heard all these companies and all of these programs are open source. What does that really mean? So for that, I want to show this idea of what is then stored on GitHub. Here is an example of a repository of a micro-school that we've had previously of talking about NumPy, which is a very useful package for dealing with maths in Python. This here is in a GitHub repository, NumPy, made by the NumPy profile. All of the code for NumPy is publicly available here. And with a nice README, they've got a very good explanation of how to use it and how to get started. And you can see that it's written in Python and all of the different languages that are involved and all the people that have contributed to it, all the people that use it, links to all of the websites. But all of the code for NumPy is right here, open source, available. You can go into any of the folders, any of the files, and then you can see exactly what's going on. And then you can keep track of everything that has happened with NumPy, everything that's changed, everything that's been added, all of the commits that have been made, all 37,000 times that NumPy has changed. It's all here with all of its history. For another example, another previous micro-school was about Visual Studio Code. All of the code that makes Visual Studio Code is open source and on GitHub as well, right here. To go a step further, programming languages, entire programming languages like Go or like Julia are right here on GitHub, open source, every little line that makes it. To go another step further, Git itself is on GitHub, where it's publicly hosted, where you can see every last little detail, every last little feature of it. You can go even further and see that the actual Linux kernel is hosted on GitHub, where all of the code for all of Linux is here, made by Linus Torvalds himself as the main repository for the Linux kernel, which has 1.3 million commits. So you can see that this is kind of the place for all code to be. If it's ever going to be open source, this is where it ends up. So to get started with this, you can easily just make an account from the GitHub main site. It's fairly simple to get started. Then it's also very easy to get started with making a repository. And for this one, it's just an empty repository that I've made by clicking on my profile and your repositories, you add a new one. This is the first thing that you'll see with a brand new repository. And while a lot of this may look overwhelming and there's a lot of things going on here, you might wonder what's the issues and insights and security and all this. You don't have to worry about that for now. Just worry about here, this first main page is code. And this tells you how to get started, where either you can go through these blocks where if you've made this repository and then you want to make your code and then you want to make it locally, then you go through all of this. But because what we've already done is in all of this, we've made this folder, we've made our files, we've done the git init, we've done the git commits, we've added all of our things. Now we just want to connect it and hook it up to GitHub so it can link directly here and be one-to-one kind of related. That's done with these 3 lines where we do git remote add origin, where just git remote where it's somewhere else. We add the origin from where it was and to then where it is with this link to this git file here, which is this repository. We git branch into our main file, which links it with this main, which is where I said that GitHub has main and Git has master by default, but this just links them. And then after we've committed our code and saved it, now we want to copy our code up into GitHub And that's done with this git push function, where we then have to say where it's from and then where it's going. So what we can now do is just copy these lines. Do all of those, and then it has been set up now. That's, I refresh this page. Now we have the files that I've added into the Git repository here. Now everything is linked and it's worked and your code is saved. Now also, if you have the terrifying prospect of, if you have all your year-long projects on your laptop and you're very proud of what you've done, but then the laptop falls in a river or something, all your code disappears. Now you've got it hosted on GitHub. All you have to do is you can do this git clone functionality, where I can type, if I want any other repository, I can git clone and then add in a file, link to a GitHub. I can, to get from this GitHub that I've linked it now to, this repository, the same way that I did now git push to send the code from my computer into GitHub. The opposite, if I want to get the code, I git pull in the same way. So I can git pull, I think it's origin main, yeah. And that will then pull all the code from the online repository into my computer. And then we can see here, it's already up to date, nothing's really changed. If I want to do something here of adding a README, for example, I can do that just by writing it in here, which is not the best way to do it, but just for this example, it works. Then I can git pull origin main. That will then show that it's okay. It's seen some changes. It's seen this README. Now it's pulled it locally. Now I have a README on my local machine. Now they are in sync. But now let's say I want to add something to this public repository, or if I want to go to the Linux repository. If I want to add something to Linux, then what I can do is I can add a suggestion or what's called a pull request to the admin of this repository with this new feature and with this new code, and then say what I've done. Then they can go and look on their inbox and it'll say, okay, this has been suggested as a change. These are the lines of code that have changed. Do you want to accept it or not? So now as an example of that, I will add another file of, for example, I'll add a Go file, another empty one, but you can use your imagination to extrapolate this, of what adding different files is like, or what adding different changes is like. Now what I need to do is to, okay, sorry, that was my mistake. I skipped steps. I need to first make a branch. Oh, let's now do there's a Go file. Let's make a new branch of adding a Rust file. Now that's where I am. I'm on the Rust file branch. Now I can add a Rust file. That's now here, but again, just to make sure. Now main. Now it shouldn't be that because I didn't commit. Sorry. I can go back here, git add dot git commit. Say what I added. And this added actually both, because these are the changes that have been made. But either way, you'll still see what I mean when adding it to the remote repository. I can now go and, now that committed to the Git repository, I can git push origin the main branch, sorry, I realized there my autocomplete skipped a step for me. I committed it again to the main branch, but now I need to commit to a new branch of, let's say, Rust file. And now you'll see immediately on this GitHub, there is this new yellow box that talks about a pull request. I can now come over here as the admin and the owner of this repository. I come over here to compare and look at the pull request. This is me making my own pull request, but usually you will create this and send it off and then hope that the owner or the admin of the repository will accept it. The descriptions for these should be much better and much more detailed, and they are, if you look on public GitHubs, they do have typically formats that how they want you to talk about your pull request and what information to include and how to format it. But for this example, we'll just do the basics of now I can create a pull request with this commit and change. It'll check to see if it can merge automatically. I don't know if I have time to talk about merge conflicts, but I'll quickly brush over it. But now it sees, okay, there's no conflicts, everything works. This is then what I see as the admin and the owner of the repository. I can now merge this pull request. I can edit the commit message if I want to and confirm that. Now it's added. Now if I go back to the main branch, then there's these new files. But sometimes now you can imagine if there's a team of 10 people working on things, if two people take the main branch, they branch off their own, they want to make their own changes. Someone changes a function to say something, someone changes a function to say something else, to print hello world to hello Rust to hello Go to hello NITheCS. Then if they both try and merge their branches back into the main branch, then there will be a conflict because one will change one line to something different and the other will change to something very different as well, that they will then be in conflict and they're trying to change the same thing. Then the admin or the owner of the repository will have to look at that and then resolve the conflict and see, okay, well, which change do we actually want in which part? And then you can pick, and there's a very nice interface for that makes it very clear what are the changes and what are the differences. Git does that itself as well with, you can do a git diff main and your branches, and that will then compare the merges and the merge conflicts, and then you can resolve those. But this is then also something that makes it very, very easy to work in teams and work on different people branching off different features and different parts of the code without all, if you imagine like in a Google Docs where you would then all just be typing randomly on the same file, it gets very cluttered and very chaotic at once, especially if there's 10 of you, or like you saw with the Linux repo with 1 million commits. You can imagine all of those 1 million commits all at once. It's going to be very, very chaotic. But again, now just to emphasize the very niceness of GitHub and Git, here it keeps every last little change that's ever happened from this repository. Now it even talks about this merge request. I can see the hash. I can browse the repository at this point. I can go back to another point of the repository to see what it looked like before all these changes. I can go and look exactly what this merge request was, what happened, this file was added. It'll tell you in more detail if you change lines of code. It'll highlight it in green if you add it, or in red if you removed it, and it'll show all of these changes that have been made. So this is a way to look at every last little detail that's ever changed with your code. And I hope by now the point is getting across that this is something that you want with every bit of your code, even if it is just you working on your own repository. You want to see everything that's changed, everything that you've done, everything that's been improved, all of it. You want to just have it here, and you can see how easy it is just by git add, git commit, git push, git pull. And another thing in VS Code, which I showed in the previous micro-school, is that there's a very nice feature here of source control, which does all of these things for you, where here they would show up if you've changed any files. If I can I'll add a new Julia file, for example, that then shows up here as this has been unstaged. It hasn't been changed. I can discard the changes. I can open the file. I can then usually now stage the changes. Now that's my git add dot. And from here, I can commit, or I can do it all directly. And here go commit and push. Here it'll prompt me for a message. And I can close that. It will then load, and then it's sent off. Now, when I go back here, I refresh the repository. that should have worked better. It should show up here, or it should work the same. I might be on different branches. But yeah, sorry, to wrap up on that malfunction. But yeah, as the more you use this, the more you'll get familiar with it very quickly. And then you'll see there are many, many, many other features that you can use with Git and GitHub. And all of them just add to the experience and adding and making it better and more useful. But for now, this is all you really need to keep track of your own code and to commit and contribute to open source code. The last thing I want to mention of this idea of pull requests and that, it's all fun and games. You can do it with your own repository and your own, where you are the admin and the one committing the code. But if you wanted to commit, like I said, to something like the Linux kernel, what you can do is there's this option to fork here. And this fork option basically just lets you copy this entire repository into your own repository, where then you can make your own branches, and then you can make a pull request to merge those with the main branch. So if you see some open source online code that you want to commit to, you come over to the repository, you click fork, you let it clone the repository into your own profile, and then you can work on it as if it's your own repository. And then every change you make, every time that you add a new commit, you try to merge a branch, that will then send it up into the main repository as a pull request, which will hopefully get accepted. And then there you go, you've committed to open source code. So I'm running a little bit over time, but I hope that this has been useful for you. I hope that you can see now why this is essentially like having the save function on any piece of software that you write, that you really, really want it wherever you are. And that with Git and GitHub, they are the perfect pairing that keeps all your code synced and open and adds to the open source software world. But Git on its own is a very good just save feature, which keeps track of every little bit that you've changed with your code. And I'm sure that you'll find a lot of use with it and a lot of points where you think, wow, I'm really glad that I had that. So with that, I'd like to wrap up. I'm already over time. Yeah.
Cool. Thank you so much, Dean. If anybody knows how I code, this talk kind of felt like a personal intervention.
It was.
Especially when you give those 3 examples at the start. Anyway, just so everyone knows, if you did miss one of these steps, don't worry. We are recording it and it will get uploaded to our NITheCS YouTube channel, just like all the other micro schools. And more of these GitHub or other topics that we cover are planned in the future. So we'll go into more detail. And if you have any suggestions on what to cover, whether it be for GitHub or anything else, please don't hesitate to email us. All the contact information is on the NITheCS website. And that's pretty much all I have to say. Thanks again, Dean. Thanks for everyone for attending. And we look forward to seeing you again in the next micro school. Thanks, everyone. Cheers.
Thanks.